All right, I started this live video because I'm gonna make it really short. I did quite a bit of research on YouTube and couldn't find something that really explains how uh, volt resistance and ampere works. There are many people asking questions and there are responses to those. There are actually good responses and explanations are really good if you are an expert on this field. But if not, there's always confusion. How? Why volt, ampere, and resistance work? I mean, why do we need that? There is something vague over there on almost every explanation. So that's the reason I made this setup with my this pad and little oscillator here to explain actually how a circuit work, what is circuit and how it works, how resistance, the resistors are important for a circuit, and what does it mean? Like the single resistor right here, you see, and there's another one right here. What do they mean in this circuit? This is pretty much a simple circuit. There's a power comes here, that's the positive, and that's the negative side, and these are connected to this oscillator that reads the volt. As you see over there, it's 16.285. It's kind of changing up and down volt. And I already check the amperage. I'm not going to try again here on this video, but that the ampere is the current is for this simple circuit. It is 1.12 and that's what it comes here. And the voltage is, as you see here, it is 16.28, let's say 25. And now let's do a little bit formula here, but I'm going to make it really simple. And first of all, let's start from the question. When we do this circuit, let me just actually move these away. So we know that it's 16.25 volt. And as you see here, there's positive and there's negative. And there is this resistor, one end connected to positive line, and another resistor here, it's connected again, the positive line. This is like whole line is connected. And this end is open, it's not connected to negative, because if we do it, pretty much we're closing the circuit, and then things are happening these two resistor. Now I'm gonna tell you, like, this is definitely a very simple circuit. Why is it a circuit? Because there's positive end comes and then resistor inside the circuit. It's something that can possibly consume electric, as simplest way to say, or current or electrons, whatever. But let's just say electric for the sake of simplicity. And if we don't use any of these resistors, if we take them outside the scope, right now we have a current comes all the way to this breadboard. Oh, by the way, this is called breadboard. And it comes all the way to this breadboard, and it is 16.25 volts and 1.12 amp, but it just stays here. It's just, we cannot possibly say circuit to this because there's nothing here to use this power. To make this a circuit, we have to put something inside the scope. That's what this is. This is pretty much the simplest circle we're gonna make. Now, if I put this resistor, which is, this resistor is actually 1.2, you can get that value from the color bands. If you see here two reds, that's how I know that it's 1.2 kilo ohm. And if I put it right here, put one end on the positive, touching the positive, and the other end touching nothing, just it's not connected to negative. So right now this is a circuit, but it's an open circuit, means it's not connected, like positive and negative is not connected to each other. That's why it's not a closed circuit. So it's not functioning right now, but we can definitely name it circuit. I'm sorry if I shake the phone because I'm holding it with my left hand. This is a circuit because we have a one resistor inside. The Definitely the electric, I should say, is simplest way to say it, or electrons are moving from, they're not really moving, but they have an access to this resistor right now. They are coming and they're waiting right here. Potentially waiting over there because there is no current yet. So pretty much it's the potential power is inside the resistor too, but it's not moving. That's why it's not doing anything. It's not heating it up. It's not functioning. It just means nothing when there's no current. But if I put one cable, which is, I can use this red jumper cable, if I put one end to right there, which right now this is connected to this end of the resistor and the other end is not touching anywhere yet. If I touch it to this negative side, that means I'm closing the circuit. What happens is at that moment, I can actually do it because I know that the resistor over there, it is a good enough resistant resistor, so it will resist this current. And if I put it on, now definitely there is a dissipation over there, if I say it the right way. But if I touch my finger, I don't feel any heat, even though this circuit is closed. Circuit means it's running circuit right now. It's definitely running. The electrons are moving from actually the left side, like going through this red cable and coming to this end of the resistor and then go that way. But this section of the resistor right now resisting 16.25 volt and 1.12 amp. And it is resistant. It says, hey, I can resist you because I am qualified enough to resist you because I'm 1.2 kilo ohm. And this is how it works. By the way, I already told you this is 1.2 kilo ohm. And why this 1.2 kilo ohm is resistant this circuit, it's because of this formula. The formula of watt is something that actually the electric power, that's what it is important in circuits. Like the watt is the one that ruins the circuits, heats up the circuits, or running everything. And it has to be just perfect, the amount of wattage power that the circuit should be run without any problem. To calculate that one, we know this formula, P power, it's watt pretty much, equals volt times the current, it's I. And in this case, we know that our voltage is 16.25 times, and we know that our current is 1.12 ampere. And this would give us approximately 18 point, I think, as far as I remember, I already calculated before the video, it was 18.2 watt. So that is what it is. Right now, the power is in this circuit, let me check if it is burning. No, I can kind of get a little bit uh, heat, but it's not really going to ruin the resistor because it's just the right size. I could have put a little higher resistor, but I just want to demonstrate you the perfect sweet spot. So now we know that it's 18.2 watt in this circuit right here. Uh, and now, if we, in this case, of course, you don't see, this is only a wattage. It doesn't tell you what resistor, how are we going to decide the resistor that can possibly handle this circuit. So we found the watt, the power of the circuit. Now we are going to find the resistor of the circuit. And we know that resistor is from the Ohm's law. Resistor is the volt divided by current. And in this case, our volt is 16.25. And the 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 ampere that we need, we don't know that one. How many ampere we need, we don't know that one. In order to find that one, first of all, we need to know what kind of resistors we are going to be using. In this case, this resistor is a small electronics, the resistor that for small electronics, not high power electronics. Average is 0.25 watt. But if we look at here, our power is 18.2 watt. So if we directly use like 1.12 amp, it will definitely burn any resistor that lower than 1.2 kilo ohm. But now, in order to find this one, we need to first figure out how many kilo ohm or ohm resistor we need for 0.25 watt, not 1.1 watt. To figure that out, let's just clean this again. And in this case, we're gonna do this formula. So we need a current, what current we need for the power 0.25 watt and for 16.25 volt. So that is actually the formula of the current. So it's power divided by volt. And so we're looking for this 0.25 watt and divide by 16.25 volt. So that is going to, I already calculated that before the video again, that is 0.015 amp. So this is what we need for this. Actually, this is not what this is something that we don't need it. This is something that we need to run in this circuit. Maximum current, we should allow this circuit to run. The speed should be 0.015 amp from this formula. So now we have the required current 0.015. So if we put this 0.015 amp inside the resistor formula, that's R equals the voltage divided by current. And in this case, our voltage is again 25. And now the required amperage is 0.015. And that's volt. And the result is going to be 1.083. Yeah, That's as far as I remember, this is what it was. But if you divide it, so you should be getting this value, 1083. That is the resistors. That's what the resistor should be. So 1083 ohm. That is approximately 1 kilo ohm. It's a little above than 1 kilo ohm. So we can definitely use 1 kilo ohm, but in that case, we're gonna feel heat on that resistor because we need a little bigger than that one. So that's the reason I step up to the one above resistor, which is 1.2 kilo ohm, which is right here. So if I touch it, I feel that the dissipation, the heat thing. If I tell you the meaning of it, so it has a heat. It is resisting it, but it's not burning, and it is fine. I think it can be used for this circuit. And we know that there's a 16.25 volt here, and this is resistant. There's a little bit heat. That means in this part, this section, we don't have 16.25 because this resistor functioning. It's a pretty much in this circuit, it says I'm a circuit and my goal, my job is in this circuit, make a little bit heat. Whatever the resistant power I do, for that resistant power, I'm creating a little bit heat. And that is what the function of this circuit. And in here we have 16 point probably 1 volt, and this 1.2, actually we can kind of check that one. Now if I put the oscillators 1 and 2 here and the other hand right here, we should definitely see a little less than yeah, it's 16.1 volt. A little, it's going up and down. And that is what it is. And here, though, we have another resistor. This is 1 kilo ohm. I'm gonna put this like in a little bit aside, and I'm gonna move this up. Now this circuit is open. And if I plug this jumper cable into here to this 1 kilo ohm, this will definitely heat up this 1 kilo ohm. And here I'm putting up, and I'm kind of careful on that one. Yeah, it is heating up. Definitely, I can feel it's kind of, it will heat up. It's not really too terrible, but there is definitely quite a bit of heat now. Why? Because current is 0.083 ohm more than this 1 kilo ohm resistor. So this 1 kilo ohm resistor cannot handle this current. That's why it's heating up, and that is the function of this resistor in this circuit. So I hope this explains everything. And this is what the circuit is. I know that there's a common mistake people do, like they're asking, like I have like 12 volt and 1 amp, and I want to make it like a 0.5 amp or a little higher amp. It is not what it is. What amp is happening depends on what kind of components you have. And definitely there is a limitation on here. The amperage is 1.1 until this the power supply. But after this, in order to get the amperage you want, you just play with your components, and definitely you cannot make more amperages here unless you lower the voltage. But pretty much overall, the power, I'm sorry, this is resistant. Power of this circuit as we calculated previously, 18.2 watt, that is not going to change. That is going to be always same. So whatever you use in this circuit, whatever the components you use, uh, if you combine all the functions together, the consumed functions, it will equal to 18.2 watt. Doesn't matter what ampere you have, or volt you have, or heat you have, or resistance, or LED light, whatever it is, total is going to be 18.2 watt if your circuit is closed. I think that's good enough. I don't want to make it longer. Thanks for listening. And you can follow me for these kind of videos. Thank you so much.